Okay, let's look at 8 through 11. What do I got here? It looks like a circle and a line again. So if I have a circle and a line, they're probably going to touch in 2 spots at the most. So let's see if we can find it here. I'm going to do substitution. Again, I'm going to get x by itself, and that would be y plus 11. So I'm going to plug y plus 11 in for, x there. So it'll be y plus 11 squared plus y squared equals 23. This will double distribute. Y squared plus 11y and 11y, it's 22y, plus 121 plus y squared is 23. I'm going to get 0 on one side and rearrange. 2y squared plus 22y. If I subtract 23 here, I get 98. Can divide everybody by 2. And I get y squared plus 11y minus 49 equals 0. Ew, this does not look good for me. Okay, I don't think this is going to factor. Okay, so we're going to do quadratic formula here. And this is going to give us the y value, I think. Let's double check to make sure they use quadratic formula too, because I don't want to waste a bunch of time if that's not the case. They did what we did. Oh, they actually had the same problem as me. Yep, so they're going to use quadratic formula too. Okay, x equals negative b plus or minus the square root. B squared minus 4a times c is negative 49 all over 2a, which is 2. Negative 11 plus or minus the square root of 121 minus 4 times negative 49. That's 317 over 2. I'm plugging some numbers here to see if this even breaks down at all. I don't think it does. I'll try 9. Okay, yeah, I don't think it breaks down. So that's what y equals. So now I got to plug those in to find x. Disgusting. Okay. So I'm going to write this out a little bit better here. So y equals negative 11 over 2. I'm going to love math. Plus the square root of 317 over 2. That's one of the y's. And the other y is negative 11 over 2 minus the square root of 317 over 2. Okay? So x is going to be x minus all of this equals 11. So x minus, this is a horrible problem, negative 11 over 2 plus the square root of 317 over 2 equals 11. You would distribute this, so it'd be x plus 11 over 2 minus the square root of 317 over 2 equals 11. And then you would subtract 11 over 2. 11 minus 11 over 2 is 11 over 2. And then you would add square root of 317 over 2. Okay. So x equals for this guy positive 11 over 2 plus the square root of 317 over 2. And I'm going to guess, I'm going to go on a limb here, the x here is going to be 11 over 2 minus the square root of 317 over 2. I don't know that for sure, but I would skip this problem if I were you guys. I would not do this problem. It's a little frustrating looking. 11 over 2 plus square root of 3. This is not worth the frustration for you guys, okay? So why don't you go ahead and skip it, but now I just want to know if I get it right. Result, like, I want to throw the computer just typing this stupid thing in. It's wrong. Let's see what it is. I'm quitting too. What? Oh, an I? Where was there an I? Okay. Well, there's an I somewhere. We missed that one. We're going to skip that one. We're not doing that one. Okay, I'm going to do this one, though, with elimination. So I know I can do this one. I'm going to multiply the whole top by -7. So I get -7x squared minus 7y squared equals -210. The bottom is 7x squared plus 3y squared equals 18 still. -4y squared equals -210 plus 18. -192 divided by -4. Y squared, excuse me, is, what does that say? Y squared equals 48, which means y is the square root of 48. So which one of these has square root of 48 for y's? It's one of these two, B or C. Now plug that in to find out what x is. Let's plug it into the top one. X squared plus the square root of 48 squared equals 30. X squared plus 48 equals 30. It's going to be the one with the i's. If you minus 48 here, you get -18. X squared is -18. Square root negatives, and you get i's. So it's the one with the i's and the square roots there. Okay, we did okay on that one at least. I'm sorry about that last question. That was just so bad. Okay, what do we got? True or false? If you have a nonlinear system, can you have real number solutions and imaginary solutions? Yeah, we just did. Just did. Okay, and if you have a graph of a nonlinear system, a line and a circle, you can have two. That's true, right? It can a circle and touch it twice. That's true. It could touch it once or not at all, but it definitely could touch it twice. Okay, so that's it. We didn't do that one, so we're looking at 90%. You guys can do that.